Hello and welcome to GER Hub Mathematics and Statistics lessons. Today we shall begin our solver series on set theory part 2. So in our solver series on set theory part 1, we discussed and explained 5 questions on what we had learned in our set videos. Okay, so please look at that video and give it a like. If you like the content, give it a like, and let's continue. Okay, in today's video we shall be looking at several questions on set theory to extend our knowledge on set theory problems. Okay, so let's start with the first question. So the first question here demands the following: that we find x union u, x intersection u, or x union y, x intersection y, x intersection y complement, and x intersection y all complement. Now, what are we given as our mu? Our mu is the universal set containing all the letters of the alphabet, okay? And x is the set containing A, E, I, O, U. Y is the set containing E, B, C, D, F, and H, okay? So let's see, what do we do? Let's get on with it. So solution, let's start with obtaining x union u. Union y, sorry. Okay. Now we shall look at x. X is the set that contains A, E, I, O, U, uniting with the set y, which contains E, B, C, D, F, and H. Now, remember from our videos in set theory that the union of two sets is a new set that is formed by combining the elements of the two sets without any repetition, okay, of any element that occurs more than once. So now let's see, we have in this set A, so I'm going to write A. We have E, we have I, we have O, we have U. Now note that A occurred just in this set, but E occurred in both. I didn't write my E 2 times, I wrote it just once. So whether an element occurs more than once, you only write it once. Now I is found in this set but not in this set. So the union of the two sets will contain the elements found in both of them with no repetition for any element that occurs more than once. So now the next element I'm going to write is E. I've already written E. B, I'm going to take B. I'm going to take C. Now D, I'm also going to take. F, I'm going to take. And then H, I'm going to take. So this gives the union of the two sets. Take note, there is a set, there's an element repeating, and that element is E. And although it repeats in both sets, I have only written it once. So in the union, it appears just once, okay? So let's go to the next problem. II demands that we find x intersection y. Now, x intersection y, remember what we said in set theory, that the intersection of two sets gives a new set containing elements found common to both sets. So what element do you have common to both sets? It is just the element E. Now that tells you that x intersection y is a singleton. Remember in our videos on set theory that singletons are sets that contain only one element. So singletons are sets that contain only one element. They are also called unit sets, okay? So x intersection y is the set that contains elements found common to x and y. And what element do you find in x that you also find in y? It is the element E. And since this element is the only element in the set x intersection y, it means x intersection y is a singleton. Now let's go to question number 3. Now in question number 3, we are asked to find x intersection y complement. So I'm going to put a question mark here, and let's start with obtaining y complement. So what is the set y complement? The set y prime or y complement is a set that contains elements you find in the universal set but not in y. So now since the universal set contains all the alphabets and Y only contains some of the alphabet ranging from E, B, C, D, F to H. Now let us take out this set Y. Let's take out all the elements in this set from the universal set and write out what is left. So we have A, we have B, C is there, so we have D also, we have E, we have F, we have no G, so I'm going to write G, we have H, then I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now, these are the elements in Y complement. Now, take note, if you have these elements in Y complement, then it means that X intersection Y complement will be the elements you find common to X and Y complement. So what elements do you find common to X and Y complement? In X, you have A, E, I, O, U. Then in Y complement, you have A, G, I, G, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So now what elements do you find in X that are also found in Y complement? You will notice first on the list is A. Now there is E in X. Do you have E here? No. There is I in X. Do you have it here? Yes. So I'm going to write I. What other element? There is O in X. Is O here? Yes. So I'm going to write out O. And there is U in X. Is there U in Y complement? Yes. So this will make the intersection of the two sets. So the intersection of X and Y complement gives you this. Now let's go to number 4. Now we are asked in number 4 to find X intersection Y all complement. So remember, the complement of a set it will contain elements found in the universal set but not in that set. We had obtained X intersection Y to be E, the set that contains only E. So X intersection Y complement will be all the elements that are not E in the universal set. So to make it easy, I'm just going to write the universal set minus E, and that will give us the set we want. That means writing the set A, B, C, D, no E, then continue with F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So what am I doing? I'm writing out all the elements in the universal set that are not found in the intersection of X and Y. So the intersection of X and Y gave us E. Now if you remove E from the universal set, it will give us the set X intersection Y complement, the set containing all the elements that are not in X intersection Y but in the universal set. And that concludes problem 1. Okay, so let's go to problem 2. Let's go over to problem 2. Now problem 2 demands the following: that we find all these intersections and unions, and we are given this set. Okay, the set containing all these mathematical operations, whether mathematical or logical operations or inequalities. Let's see. So if mu contains this, A contains this, plus multiplication greater than and less than or equal to, and B contains division less than or equal to, not equal to, C contains this. Now we are asked to find A intersection B. So let's start with the first. A intersection B will be the symbols or the operations found common to both sets. So what symbol do you find in B that is also found in A? Now you have the less than common to both of them. Division is found in B but not in A. Addition is found in A but not in B. So the element you find common to A and B is just the less than or equal to. So I'm going to write it out. And that tells you that A intersection B is a singleton. because it contains only one element. Now you have A, the next one is B intersection C. So what is B intersection C? It will give us the set containing symbols or operations found common to both B and C. Now what do you find in B that you also find in C? It is the not equal to symbol. Okay, the not equal to symbol is the only symbol common to both of them, so I'm going to write it here. So it means B intersection C is also a singleton because it contains only one element. Now number 3, we are asked to find B complement intersection C. So I'm going to put a question mark here and then obtain B complement first of all. So B complement will be the symbols you find in the universal set but not in B. So what symbols do you find in the universal set but not in B? I'm going to write them out. In the universal set, you have addition, which is not found in B. You have multiplication, which is not found in B. Division is found in B, so I'm going to skip. You have the less than, which is not found in B. You have the greater than, which is not found in B. You have the less than or equal to, which is found in B. You have the not equal, the greater than or equal to is not found in B. Then you have, and I think that's all. So the not equal to is found in both sets. So this is B complement. Now we are going to unite or intersect B complement with C. Now remember, let's bring C down here. C contains the greater than or equal to symbol. It contains the not equal to symbol and the greater than symbol. So B prime intersection C will be equal to the elements, the set containing elements common to these two sets. Okay, so what elements do you find common? This and these are common, so I'm going to write the greater than. Then not equal to is not found. Then the next one is the greater than, so it is found common to both sets. So this set is a dual. Okay, dual is a set that contains two elements. Now let's go to number 4. Now number 4 demands that we find A union C. So the union of two sets is a set that contains elements found common to both of them, as well as elements found in both of them. So A union C will be the set that contains elements you find in A that are not in B, elements you find in B that are, or elements you find in A that are not in C, plus elements you find in C that are not in A, plus elements you find common to both of them. So what elements do you find in A? Let's write out the elements of A. These are the elements of A. As a quick reminder, uniting them with the elements of C, these. Let's see what it gives. So it will give us, now you have addition found only in A, I'm writing it out. Multiplication found only in A, I'm writing it out. Greater than found common to both of them, so I'm going to write it once. Less than or equal to found in only A, I'm going to write it out. Greater than or equal to found in only C, I'm going to write it out. Then the not equal to found in only C, I'm going to write it out. Okay, so note that the union of the two sets contains elements you find either in both of them, either in A or C, or both A and C. So addition is found only in A, multiplication is found only in A, greater than is found common to both of them. You don't write it twice, you write it once. Less than or equal to is found only in A. I've written it out here. Then greater than or equal to is found only in C. I wrote it out. And not equal to is found only in C, and I've written it out. Okay, so that brings me to number 5. Now number 5 demands that we find A union C complement. So what would A union C complement give us? It will give us uniting A, which is this, with C complement. Now C complement, let's write out C complement. C complement will be the set containing elements found in the universal set but not in C. And in C, take note, we only have the greater than, the not equal to, and the greater than or equal to, the not equal to, and the greater than symbol. So now if you remove that from the universal set, let's see what remains. So I'm going to remove them. Now Removing C from the universal set leaves us with addition, which is in the universal set but not in C. Multiplication, which is in the universal set but not in C. It leaves us also with division in the universal set but not in C. The less than symbol is in the universal set, not in C. The greater than is in C, so we won't write that out. Greater than or equal to is in C, but this is not. Then not equal to is also in C, so you end up having C complement to be the set containing addition, multiplication, division, less than, and less than or equal to. Okay, so look at it carefully. So you have addition in the universal set, not in C. You have multiplication in the universal set, not in C. Division in the universal set, not in C. You have less than in the universal set, not in C. You have greater than in both sets, so we skip. You have less than or equal to in the universal set, not in C, so we write that down. Greater than or equal to is in C, so we won't write that. Then not equal to is in C, so we won't write that, and that gives us this. Okay, now when you unite both sets, you are going to have addition, which is found common to both of them. Multiplication is found common to both, so they will be written once in each case. Then greater than is found only in A. I'm going to write it out. Less than or equal to is found common to both of them. I'm going to write it out. Then the next one is division. So this set will contain 1, 2, 3, 4, 5 elements. Okay, now that being said, let's go to question number 6. B union C complement, or B union C, sorry, B union C. Now for B union C, I'm going to write B. B is division, less than or equal to, and not equal to. Uniting that with C, C is the set containing greater than or equal to, not equal to, and greater than. Now, what would that unite to? That will unite to division, which is found only in B, is written out. Less than or equal to, I'm going to write it out. Not equal to, I'm going to write it out. It is found both ways, so I'm going to write it once. Then greater than or equal to, I'm going to write it out, okay, because it is found only in one place. Then greater than. So this will give us B union C. Remember, I will keep emphasizing that the union of two sets is the set containing elements found either in both sets or found either in the set B or C, or found in both sets. So when forming the union, look at the elements in B alone, write them out. Look at the elements common to both of them, you write it once, or write them once. Then look at the elements found only in C, and you write it together. That will give you the union. Okay, now for number 7, we are asked to find A complement intersection B, and that will be A complement will be the set containing elements in the universal set but not in A. So look at the universal set. These are the universal set elements. Look at the A set elements. So let's write out A complement. A complement would have the less than. Okay, let's start with the division. Why am I starting with the division? Division is found in the universal set but not in A. Then it will have the less than symbol, which is in the universal set but not in A. The greater than symbol is found in A, so I will write that down. I will skip. The less than or equal to symbol is found in A, so I will skip, and I will go to this, the greater than or equal to. Then I will go to the not equal to symbol. Okay, so that will give me A complement. Then uniting it with B, B is a set containing this, division, less than or equal to, and not equal to. Okay, so let us quickly intersect. The intersection of the set will contain elements that are found common to both of them, so that includes division. Is there any other one? Let's see. Okay, you have the not equal to symbol, so this set is a dual also. Remember, a dual is a set that contains two elements. Now the next is number 8. So in number 8 we have B complement union C. So let's write out B complement. We remember we obtained B complement earlier to be this, so I'm going to write it here just for reminder's sake. This is B complement. Okay, then uniting it with C, B complement unites with C. This is C. Okay, now the union again will contain elements found only in B complement. Let's write those elements out. Addition is found only in B. Multiplication is found only in B. Less than is found only in B. Then greater than is found common to both of them, so it will be written once. Greater than or equal to is found common to both of them, so it will be written once. Then not equal to, and that gives us the union B of B complement and C. Then for question number 9, we are asked to find A complement intersection C. So I'm going to write out A complement. A complement, remember, gave us this division, less than, greater than or equal to, and not equal to. Then intersecting that with C, C contains elements greater than or equal to, not equal to, and greater than. So let us quickly intersect those sets. If you intersect the two sets, what are you going to have? You are going to have elements found common to both of them. And what elements are common to both of them? Greater than is found in both ways. Not equal to is found both ways. So those two elements make up the intersection, and that will give us this. So the set is also a dual. Now the last question is question number 10. Question number 10 demands that we find B intersection C complement. Now B is the set that contains division, less than or equal to, and not equal to. So intersecting that with C complement is a set containing elements found in the universal set but not in C. So what elements do you find in the universal set but not in C? They are addition, is not in C but in the universal set. Multiplication, not in C but in the universal set. Division, not in C but in the universal set. So I'm going to bring them out here. Addition, multiplication, division. Okay, now you have in C you have the less than, so I'm going to bring it here. You have the less than in the universal set but not in C. You have the greater than, so you see. Now I'm going to write the rest are less than or equal to, greater than or equal to, and then not equal to. So these are the elements you find in the universal set but not in C. So this set here makes C complement. You can verify that, and let's see. So you intersecting the two sets gives us what? Now what elements do you find common to both sets? You will notice that division is there. You have less than or equal to there, common to both sets, and you have not equal to. So these are the elements common to both sets. You will notice that all the elements in B are found here. So B is more or less a subset of C complement. Okay, so when you intersect a set with its superset, it will give you the smaller set, and that is what we have just shown here. So the intersection of B and C complement gives the set containing division, less than or equal to, and not equal to. And that brings me to the end of question 2. Now let us go to question 3. In question 3, we are given this. So let's see. The solution to this problem is as follows. So we are given that to solve. Natural numbers will make the set mu. That's the universal set. Factors of 20 will make the set F. Factors of 20 will make the set F. And S, all multiples of 3 that are less than or equal to 36. So let us start with writing out the sets given to us. So the natural numbers, let's start particularly with 1. Let's assume our natural number starts from 1. So there is a natural number system that starts from 0, but I'm using the one of 1, okay? The one that begins with 1. So this will be 1, 2, 3 to plus infinity, okay? That will be the set, the universal set. Then F will be the set containing all the factors of 20. So what are the factors of 20? The factors of 20 will be all the numbers that can divide 20 without leaving a remainder. So I'm going to take all the factors of 20 as 1, 2, 4, 5, 10, and 20. So these are the factors of 20. 1, 2, 4, 5, 10, and 20. Okay. Now the next will be to write out S, the set S. We are told the set S is the set of all multiples of 3 less than or equal to 36. So the multiples of 3 will give you those numbers that are formed by multiplying 3 with the integers, the positive integers. Okay, so of course 3 is a multiple of itself. So 3 times, because 3 times 1 is 3. So 3 times 2 will give you 6. 3 times 3 will give you 9. 3 times 4 will give you 12. 3 times 5 will give you 15. 3 times 6 will give you 18. 3 times 7 will give you 21. 3 times 8 will give you 24. Okay. 3 times 9 will give you 27. 3 times 10 will give you 30. 3 times 11 will give you 33. 3 times 12 will give you 36. So these are the multiples of 3 that are less than or equal to 36. Now, having written out all the sets by interpretation, then let us solve the problem. So to start with, F intersection S would give us what? Okay, F is the set that contains 1, 2, 4, 5, 10, and 20. That is the factors of 20. And F and S is the set that contains all these, the multiples of 3 that are less than or equal to 36. So if you intersect these two sets, what elements do you find in F that are also found in S? That is, the elements common to both sets is what we want as F intersection S. So you will notice that you have the elements found in F that are found in S are, let's see, are there any? We have 1 here, it is not found here. We have 2, not found in S. We have 4, not found in S. We have 5, not found in S. We have 10, not found in S. We have 20, not found in S. So it means the set F intersection S is an empty set. It is empty. So we can write either the empty brace or this. Okay, remember in our definition of the empty set, it is a set that contains no element. Now number 2, we are asked to find F union S. So F union S will be the combination of both sets. So clearly it will be uniting. Since there is no intersection, we will just write all of them all together. So 1, 2, 4, 5, 10, 20 as elements found in F. Then 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36 will give me the union of F and S. Remember, the union of two sets is the set containing elements found either in the sets found in either set or both sets. Okay, so in this case there is no intersection, so we only would have to write out all the elements in F and S put together. So for number 3, we have N F intersection S equals what? What is the cardinality of F intersection S? Now, F intersection S gave us the empty set, so the cardinality of this set will be 0, okay? Because the cardinality of an empty set is 0. The empty set has no element, so the cardinality of F intersection S, which gave us an empty set, is 0 because it contains no element. Remember, cardinality means the number of elements in a set. So how many elements do you have in an empty set? No element. So the answer is 0. Now, for number 4, we are asked to find NF plus NS. So how many elements do you have in F will give us NF? How many elements you have in S will give us NS? So the number of elements in F would be 1, 2, 3, 4, 5, 6. Okay, so this will be 6. The number of elements in S will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 plus 12 gives 18, and that answers that question. Then finally, for number 5, N, we are asked to find the cardinality of N, the cardinality of F union S. That is NF union S. Now, we had obtained the union of the two sets to be this. So, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 elements in the union, so the cardinality will be 18. Now, you simply could have done that by adding, taking the cardinality of F plus the cardinality of S, simply because there was no intersection, okay? So, NF union S will give us 18, and that completes question 3. Now, let's move over to question number 4. In question number 4, we are given this to be our universal set. We are given H as the subset and K as the subset of that universal set. So the universal set contains S, P, L, E, N, D, O, U, R, and H contains S, P, E, N, D. K contains P, O, U, R. Okay, and we are asked to find these, and at the end compare this with this, this with this, and suggest what we notice. Okay, so let us look at that quickly. Now, as a solution to the problem, let's see. Now, for number 1, H union K will be the set that contains elements you find in H alone, added to elements you find in K alone, added to elements you find common to both of them. So, let's write S, P, E, N, D are the elements you find in H, uniting with the elements you find in K, P, O, U, R. That will give us the combined, and that would contain S, which is found in H alone, P, which is found in both of them, will be written once, E, which is found in H alone, N, which is found in H alone, D, which is found in H alone. Then we've already taken P, which is found common to both of them, so we continue to the next element, which is O, U, and R, elements found in K alone. Okay, so let's go to number 2. H intersection K is what we are asked to find, and that will give us okay, S, P, E, N, D intersecting itself with K, P, O, U, R. Okay, now if you intersect, it will mean writing out the element found common to both of them. The only element that is found common to both sets is P. So the intersection of this set gives a singleton, a set that contains only P as its element. That's one element. Okay. Now, number 3 demands that we find H complement union K complement. So let's start with obtaining H complement. What is H complement? H complement will be the set containing elements you find in the universal set but not in H. So what elements do you find in the universal set but not in H? You will notice that it is O. We find O, U, and R are in the universal set but not in H. Then L also is in the universal set but not in H. So you have L, O, U, R. Okay? Now uniting that with K, K complement. What elements do you find in K? You find in the universal set but not in K. The elements you find in the universal set but not in K are S, L, E, N, D. Then OUR is OUR is found in K. Okay, so if you remove the elements you find in the universal set that are not in K, it will give you the set K complement, and that will give you, when you unite both sets, uniting H complement with K complement will now give you this. Writing all the elements you find in H alone, H complement alone, that is L is found common to both, so I'm going to write it once. O is found only in H complement. U is found only in H complement. I'm going to write it. R is found only in H complement. Then we'll now come over here. S is found only in K complement. L is found common to both of them, and it has already been written. E is found in K complement alone, N is found in K complement alone, and D is found in K complement alone. So that gives us the intersection, the union of H complement and K complement. So going to number 4, you have H complement intersection K complement, and that gives you LOUR intersecting with SLEND. Okay, now what elements do you find common to both of them? The only element common to both of them is L, and that gives you the result for H complement intersection K complement. For number 5, you have you are requested to find this, the complement of H union K. Now notice that H union K, to start with, gave us SPENDOUR. So H union K complement will be the elements you find in the universal set but not in H union K, not in this set. So what elements do you find in the universal set but not in H union K? The first element is L, if that's not the only element. So the only element is L, and that gives us this. Okay, now let's go to VI. Now VI, which is the last question here, HK complement, H intersection K complement is what it demands. Now H intersection K gave us P alone as a singleton. Okay, now what is the element? The element of H intersection K complement will be the element in the universal set, not in H intersection K, and that will be all the elements in the universal set excluding P. So I'm going to write SLENDOUR. So these are the elements in the universal set excluding P, which is the only element in H intersection K. Okay, now for the next thing we want to do now, we were asked to compare H union K complement and this. We were asked to also compare this and this, and what we notice. Now for the first one, you would notice that the first thing we'll notice is that H union K or complement is equal to H complement intersection K complement. Okay, both of them, take note, what did we get as H union K complement? We got this L, and that was the same result we obtained for H complement intersection K complement, still L. Okay, so notice also that what we obtained as H intersection K complement was what we obtained as H intersection K complement is this slender. Okay, and what we obtained as H complement union K complement, let's see, is also slender, only that the arrangement is not the same, but the same letters are contained, so both of them are equal. SLENDOUR. Now if you remember our discussion on equality of sets, take note, two sets are said to be equal if they contain the same element irrespective of the order of arrangement. So take note, these two sets are equal, and this is a property of sets. So read or go through our video on set properties. Okay, now let us go to question number 5. Okay, so question number 5 ends our video on set theory, the solver series part 2. So let us quickly complete this problem. Now, in an examination, 18 candidates passed mathematics, 17 candidates passed physics, 11 candidates passed both subjects, and 1 candidate failed both subjects. So the first thing I'm going to do before we attend to the questions that come, is to interpret or write them out. So in an examination, 18 candidates passed mathematics. So I'm going to use M to represent mathematics. So let M be equal to mathematics. Now the implication of this is that NM will be equal to 18. Okay? Now 17 candidates passed physics. So let P represent physics, and that would imply that NP is equal to 17. Now, 11 candidates passed both subjects. So that would mean NM intersection P will be 11. Then one candidate failed both subjects. One candidate failed both subjects. Now, the candidate that failed both subjects will be N. So the number of elements that passed both subjects is NM intersection P. So if you fail mathematics, then you belong to M complement. So if you fail physics, you belong to P complement. So if one candidate failed both subjects, then it means I can write here M complement being the ones that failed mathematics, intersection P complement the one that failed physics. So the number common to both sets is 1. Okay? Now what have I done? I have used notations to represent what we were given. Okay? Now the next thing I'm going to do is to go to question number 1. We are asked to find the number of candidates that passed mathematics only. Now I would love to do this. Anytime you are given a problem on set theory, I would encourage you to start with using a set, the Venn diagram to represent the problem. So this is a 2-set problem. You can go through our videos on Venn diagram. Okay, so I'm going to use M here. I'm going to use P. Now we are told that 11 passed both. Okay, so M stands for the mathematics student that passed, the student that passed mathematics. So since 18 of them passed mathematics, then this will be 18 minus 11 passed mathematics only, and that will give us 7. So 7 candidates passed mathematics only. Now, remember, this shaded portion here is for mathematics only. This shaded portion is for physics only, if you go through our videos on Venn diagram. Now, 17 candidates passed physics. So this place here that looks like a half moon is for those who pass physics only. So this will be 17 minus 11, and that will give us 6. So 6 candidates passed physics only. Now, by the Venn diagram, those who failed mathematics and physics would belong to this group. So if you are not within this area where candidates pass, you belong here. So that is what is represented with this. Remember, this is equal to the same as N M union P complement. Okay, so let's see the number of candidates that passed mathematics only. We can get that this way. Okay, so what you do is you could use a variable, let x represent the number that failed, that passed mathematics only, sorry. Let x represent the number that passed both mathematics and physics. Okay, so now of course x is 11. Now what we are asked to find is the number that passed mathematics only. Now using set builder notation, that will be NM intersection P with P carrying the prime. So this is the portion we need, and we've already gotten it to be 7. That will be the number of persons who pass mathematics minus the number of persons who pass both mathematics and physics, and that will give you 18 minus 11, which is 7. Okay, so take note, under my discussion on set theoretic notation in our videos on set theory, notice that NM intersection P complement represents those who offered only or passed only mathematics. So only mathematics is represented with this, and that will be used subtracting those common to both of them from mathematics alone. So let's go to question number 2. Now in question number 2, you are asked to find the number of candidates that pass physics only. So physics only will be NM complement intersection P, and that will be used subtracting from physics the number of candidates that pass physics. That will be used subtracting the intersection, that is those who pass both, and that will give you 17 minus 11, which is 6. Okay, then the last question demands that we find the total number of candidates that sat for the examination. The total number of candidates that sat for the examination will be the number of candidates in the universal set, and this is obtained by adding those in the union of mathematics and physics, those who passed maths and physics, to those who failed maths and physics, and that will give you those who passed those in the union of maths and physics. Let's see. So the union of maths and physics will be N mathematics plus N physics minus N mathematics and physics plus N mathematics union P complement. Okay, and that will give you what? That will quickly give you, now notice you will end up having number of those in mathematics was 18 plus the number of those who passed physics 17 minus the number of those who passed both 11 then minus or plus the number of those who failed, and that is 1. So 18 plus 17 gives you 35. 35 plus 1 gives you 36, and 36 minus 11 will give you 25. So that will give you our result, 25. So you go over the video again and again, and you will go through and understand what we have done. So what we have just solved is this problem, and this concludes our solver series video on set theory. Do like our video, watch our video, and of course share our videos, and most importantly subscribe to our YouTube channel to encourage us to grow the channel. Thank you very much.